First of all, which one of you is using Akka HTTP? Akka? Cool. So let's start. This is about testing microservices built with the Akka HTTP and Akka. And first of all, a few words about me. My name is Tudor. I'm a software consultant. I'm based in London. And I've been building software for 15 years, over 15 years. And initially more as a full stack developer, and then in the last few years I've been doing mostly work on the backend side. And I started with Scala about 3 years ago when I was in Belgium. So then I worked for a while in the Netherlands for a company, and currently I'm working in London at hotels.com in the SEM tools team. SEM stands for search engine marketing. Basically, we have a team of specialists, search engine marketing specialists, which are creating all the ads for the hotels in the website. So basically, when you go to Google and you search, then the first few ads, the first few results are paid ads, and that's the result of the work of our specialists. And what we do as developers, we actually build a set of tools to help them manage all this crazy amount of ads and campaigns and different keywords. And we build some automation tools that make their life easier, or we give them some sort of reports. You can find me on Twitter, that's my Twitter ID, and also on GitHub. I put together for this presentation a project. I'm going to give you the exact URL towards the end of the presentation. So you can, my idea was that I created some sort of example, the way I think that microservices should be tested. I'm going to present a few different types of testing, and at the end you will have some code that you can look at in your own time, and feel free to just copy it in your project or reuse what I've done. So first of all, this is what I'm going to talk about. I'm going to give you some background, some reasons, why did I do this, and then I'll show you the project structure. And I'm going to talk about different types of testing, about unit testing, about API testing, and about integration testing. And then where can we go next, and eventually some questions. So why so much about testing? First of all, yeah, it's normal that we do want to test our code, but even more, it's very important to test these microservices based on Akka and Akka HTTP, because Akka is not typed. So until Akka typed is in a stable shape, we're still building microservices with the untyped actors. Another reason that we have to carefully test actors is that the actor behavior can mutate. So depending on some message that you received, you might get into a different state where your implementation is different. Maintaining API contracts. You have a web API, and this is not about Akka HTTP or it's just about web services in general. You want to make sure that you kind of seal your API in a set of tests that will show you in case you do some refactoring or you do some changes, or I don't know, you change a case class, and suddenly you realize that your API does not respond with the same response that was expected before. And that's very important for the intercommunication, for maintaining your protocol. Integration with the other systems. So the whole microservices architecture is based on inter-service and integration between different services. So we want to make sure that at some point, service A with service B and with service C, they work well together in a high-level scenario. And why did I started to do this because I found that documentation is a bit sparse. There are a lot of projects, a lot of examples about how to build microservices, but not that much how to test them. So I thought that I'm going to fill this gap. And my presentation is not going to be a tutorial over writing the services, but more about testing them, and I'm going to stop there. Okay? So first of all, the project structure. I'm not sure. Can everybody see this? Well, yeah. So basically, there are some boxes here. So we have the routing layer, which is Akka HTTP, and then we have the service layer, which is Akka, and inside here we have two services, the account service and the newsletter service, and we have another external API, which is the newsletter service API. Basically, the scenario is like this. I'm subscribing on a website. I'm creating an account, right? And for this, there's the account service, which is going to create my account. But at the same time, we have a newsletter service, which is going to send later on some emails. And what we want to achieve is that when we create this user, we want to subscribe this user already to an external newsletter system, right? So here, the newsletter service API, it's another microservice. And we want, when we create the user, to create a subscription in the other system. I'm going to talk about unit testing. There are different important, let's say, types. One is like how do we test an actor, then how do we test a route. I'm going to show you a bit about code coverage and a bit about how to test actors that are composed, that are linked together, which is a normal pattern. So we have the root. We have the user service actor, and then the newsletter service actor, which is basically more like a client for the newsletter service. And the scenario is that from the root, when we receive a post, we send a message, add one, with the new user. And the user service is further going to contact newsletter service with a subscribe, with a user, and return to the route with a one user case class containing the created user. And the root is further going to respond to the HTTP request. How do we test an actor? I'm showing you here some example based on the subscriber service, which is in the newsletter. And first of all, there's the companion object where I'm defining the protocol, the actor's protocol. Notice here the sealed traits request and get subscriber response. And here I can see the input and the output of the actor. Further down, we have the implementation. I simplified it here. So when you receive get1 with a ID, it will reply. It will try to search it in a subscriber list. That is its state, and either replies with one subscriber or with not found. How do we test it? So we have an abstract class test where we get the implicit actor system, and we just create this actor using the props. And then further down, we have another trait which extends this test. And here I called it test with create. And I'm basically creating the test data that I'm going to inject in the subscriber service. And later on, I'm going to check. I'm going to write some tests against this data. This is the actual specification. It should retrieve a subscriber that already exists. I'm not sure how visible is it. I'm in the first test. I know that I'm testing against a known user, the one that I already added in the actor. And I expect a message with one subscriber. And the second one, I test with an unknown username, and I expect that it should not be found. Root testing. This is the root implementation. We have a get, and then we do an ask towards the subscriber service. Basically, this root is the subscriber's root, so we can verify in the newsletter system if there is a subscriber for the user that we're interrogating. So we're sending an ID. And from this root, we use the ask pattern, and we send, because in the root we don't have an actor system. This way, the root is not an actor. So this way, we're linking to the Akka actor system, and we send get1. And in case we can have a success with one subscriber, in case there was a result, not found, or in case there was a failure, we can return with an inter.silver error. How do we test it? Basically, we have, again, a test abstract class. We create a route. And further down the specification, we use basically the DSL of Akka test kit, and we create a request, a get, and we expect. We're using a test probe for the subscriber service, and we use that to capture the actual message that comes from the root to the actor. A bit about code coverage. I'm using the SPT S coverage plugin. So I highly recommend it. Basically, you can run in my project this command, and it will give you the code coverage. I'm going to show you more or less how it looks like. So it gives you a report like this, unfortunately. And you can see the coverage, and further down, you can click on it, and you can see which parts of code are covered. I believe that this is very important to check for the coverage, because at some point you can see that you might have missed some implementation here. You didn't test it. And I recommend 100% code coverage. However, code coverage is not going to show you everything. So what does it show? In this case, what you can do in Akka, you can have, for example, different states, different receive functions, like subscribing and unsubscribing. And well, these are the states when I'm sending, for example, a request for subscribing, or other time when I'm doing a request for unsubscribing. And in both cases, we might have timeouts, right? So you don't want to write that in each state, that implementation. So you want to reuse parts. And let's say that we have another function, handle timeouts, another receive function, which we can combine with the actual specific implementation for each of the states. Now, think about if you're testing subscribing for the receive timeout, then this will appear green, and of course, you might forget to test it for the unsubscribing case. Make sense? Also, the code coverage is not going to tell you anything about the unhandled message. Since the receive function is from any to unit, it's difficult. You don't have the advantages of the Scala system that will tell you, hey, you forgot to match in a pattern match, for example. You forgot this case, so you might just forget some particular case. In my opinion, it's very important to listen to the unhandled messages. Akka will just step over it, and it will only warn you when you're in debug mode, when you're logging in debug mode, which I believe that is not acceptable for production. So there are a few ways of doing that. One is you can override unhandled, where you can log a warning or do something that you want. But this means that you have to do it for every actor, and it's a bit too much. And there's another way, is that you can listen for these, the unhandled message. So you can subscribe, you can create one actor, that's for your system, initialize it when you start your active system, and just listen for the unhandled messages. And then look in the logs for errors, of course. Composing actors. So this is a normal pattern in Akka. Is like you have one actor that has like a collaborator, right? So somehow you have to pass on maybe an actor ref to your. So you have actor A and actor B. In this case. So if you have two actors, like the user service and the newsletter service. And you need to pass on the newsletter service so that the user service knows who to contact. And yeah, you can just pass the ref, and at the testing time, you can use a test probe instead of passing the actual newsletter service. We will just pass a test probe, and later on, we can use that test probe to catch the messages and to reply with different case scenarios, right? Now, what happens when there are some cases when instead of having like a long-lived actor, like the newsletter system, a newsletter service, you would have to create, let's say, a client for doing, I don't know, HTTP requests to another service. Then what you would do, instead, you would define a factory type, and you would pass a factory function to your actor. And when the actor needs to create such a client, then it will just use the factory, create it, and in production, you will use the actual you will create an actual actor, and in test mode, you will just return a test probe that you can use further on to test your implementation. So, as you can see here, I'm passing the client factory to the newsletter service. And it's, I have down there, I have the new client function, which is using the factory with the config parameter. And here I'm showing you in the test mode, as I said, we use a newsletter client, which is a test probe, and our factory is actually returning that test probe. We don't care what kind of parameter because it's like our stub. And further on, we can use the probe in the test to verify that we receive the create message with that data. API and integration testing. I put them both here because I believe they're very, very similar. API means like testing your API, sealing it in a suite of tests, and making sure that whenever you do some refactoring, you will not break your API contract. And integration testing is about making sure that your interaction with other systems is working in a bigger scenario. So I put them together because I believe they're more or less the same. It's just sometimes if you don't have any other systems, then it's just API testing. The setup, I put together, I'm using SBT native plugin, and I'm generating Docker containers for each of the microservices that I use in my project. And then with Docker Compose, I'm going to show you a bit later. With Docker Compose, I can run all those services, link them together, and run a set of tests against this setup. In the past, I've been doing some stubbing of external APIs, but I believe that so instead of using the actual systems, the third-party systems, you start and build like your own stub. And I find that can work for a while, but it's like you're re-implementing, let's say like AdWords, Google AdWords. You're trying to re-implement their system, and you have to keep up with their implementation. And if the tests work against your stub, that doesn't mean that it will work against the actual system. So in the end, you'll need anyway a test account in the third-party system, and you should run against it. So I recommend using the actual systems and having a separate setup for the integration. So how does an integration test scenario look like? So I have my tests, and then we have the account service, meaning the account service API, and the newsletter service API. And my scenario is, as I explained earlier, when I create a user, I want to make sure that it's registered for the newsletter. So first we create the user in the account service using REST. And then normally the account service should contact newsletter service and subscribe this user once it was created. And then it should, we expect that the account service will return that user. This is, so this operation, the subscribing, in my scenario, I thought that it would not be synchronous, like it will not return basically to the account service. It could be something that is like much slower. So we don't want to wait for this subscription to happen, but we want to return immediately the created user. So the first phase of the test is to verify that the user A was created, right? And then after we wait for a while, we are going to create another request to the newsletter service and retrieve the subscription for this user. This is like after a sufficient amount of time that we believe the subscription should have been created. And we get the response, and basically it's verifying in this response that the user subscription exists. This is how the test case looks like. I'm using here some, I created some sort of, the account and the newsletter, there are REST clients. So behind this account.userCreate, there's an HTTP call and an API call. So we create a user, and then we wait for 500 milliseconds, and then we try to get a subscription, and we make sure that it's 200, this means it exists, and further on we verify that that's a subscription username, is the user details are the same with our test data. The way you can run it, so there's the account service test project, and we run the tests. We're using here a specific configuration, CI-conf, which allows me to specify different hosts for, you have it down here, allows me to specify different hosts for the backend, the newsletter backend. And as you can see, this in the Docker compose file, I'm defining the newsletter service and the account service, and I can provide some extra environment variables like the newsletter host, which is the linked container newsletter service. that was all so far. What you can do next is, if you think this is valuable for you, fork the project on GitHub, use it in your current projects, and I would like to hear your feedback. And if you want to contribute with some pull requests, that would be awesome. Any questions? Cool. Then enjoy sourdough.